Hey guys, Mr. A here. Today, we're going to talk about finding quartiles and mean absolute deviation. But first, what is a quartile? Essentially, as far as statistics is concerned, a quartile is just something that is separating the lower quarter and the upper quarter of your data. They're usually referred to as the first or lower quartile, which is the median of the lower half of your data, or the third or upper quartile of your data, and that is going to be the median of the upper half of your data. The reason why there is no second quartile is, well, that is your median. Your median serves as the center point, which separates the upper and the lower half of your data. Let's start with a little median recap. In order to find the median, you need to find the number that is in the centermost point of your data. Step 1, you have to take all of your information and put it in order from least to greatest or greatest to least. Here we've already got some data. There are 17 points of data written up here on this board. We need to find the point that is in the middle. So 17 is an odd number, so all we really have to do is take 17 and cut it in half. That's going to give us 8.5 or 8.5. What we do in order to find our median in this case is simply count to the 8th number and then go one farther, and that is our median. It doesn't even matter which direction we go from. We can start at the top and go 1, 2, 3, 4, 5, 6, 7, 8. One more step and we're at 70. We can even go from least to greatest. 1, 2, 3, 4, 5, 6, 7, 8. One more step, we're at 70 again, the same point. Now that we have our median, we can use that information to find our quartile. To find our lower quartile, we're going to find the median of the lower half of the data. So, we're dealing with 1, 2, 3, 4, 5, 6, 7, 8 numbers that come before our median. What we need to do is count up to the 2 numbers that are stuck in the middle, seeing as we have an even number of numbers for the lower half of our data. We'll go 1, 2, 3, 4, 55. 1, 2, 3, 4. So it's between 55 and 65. In order to find the quartile, we will do the same thing that we do when we have to find the median of 2 numbers being stuck in the middle. We have to find their average. If you took 55 and 65 and added them together, you should get 120. Once you've gotten 120, to finish finding your average of that, you have to take that number and divide it by 2. So 120 divided by 2 gives me an average and gives me my lower quartile of 60. Next, we find our upper quartile, which has the same method. We're going to have an even number of numbers on this side of our median. We have 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8. We'll take the 2 numbers that are stuck in the middle, in this case 80 and 80, and find their average. Or, in this case, which we are very lucky, both of our numbers that happen to be stuck in the middle are the same number. In which case, the average of 2 numbers that are exactly the same is exactly that number. The average of 80 and 80 is just 80. And there we have it. Our lower quartile for this set of data came out to be 60, and our upper quartile came out to be 80. Now you give it a shot. I want you to try to find the median and the upper and lower quartiles of these 2 example problems. I'm going to give you a chance to pause the video, and then I'll come back and give you the answers to number 1. Then I'll give you a chance to pause it again, and then we'll go over number 2. So go ahead and pause the video before I count to 3. 1, 2, 3. All right, time's up. For number 1, our median should have came out to 7. And I went ahead and circled it and marked it with an M. Our lower quartile, represented by a rectangle and Q1, should have come out to 5. And our third quartile, represented by the other rectangle and Q3, should have been 8. Okay? Go ahead and give number 2 a shot. I'll give you another moment to pause the video here. 1, 2, 3. All right, time's up. I made number 2 just a little bit harder, and you had to find the average of some of these numbers in order to find your number. For our median, we needed to find the average of 70 and 75, which came out to 72.5. Next, for our lower quartile, we needed to find the average of 65 and 70, which should have come out to 67.5. Finally, for quarter 3, we needed to find the average of 80 and 90, which fortunately for us came out to a nice even 85. But enough about all of that. It's time for us to get into MAD, or also known as Mean Absolute Deviation. All this is how much of the data may vary from the mean. And this can be found through a rather long but pretty straightforward 3 steps. Step 1, you have to find the mean. I know, shocking, right? For mean absolute deviation, you need the mean. As you can see, the numbers are just the same numbers that we used in an earlier example too. What you have to do is take all of those numbers, add them up, and divide by however many numbers there are. That's going to give you your mean. Go ahead and take a moment to pause the video to get the average right now. I'll count to 3. 1, 2, 3. Once you add all of those numbers up, you should have gotten 1,200. Once you've got 1,200, there are 17 numbers up there, so you had to divide that by 17. That would have given you roughly 71. I went ahead and rounded the decimal. Now for step 2. We're going to be using that 71 in order to find out how far each number is from the mean. This is what I was talking about earlier, where I said these steps are fairly straightforward, but very time-consuming. You have to take each number and find the difference of that number and 71. So in this case, we would do 71 minus 45, we would do 71 minus 65, we would do 95 minus 71, and we would do that for every single one of those numbers. So go ahead, pause the video here. This is going to take you a moment, so grab a pen and paper or a whiteboard, marker, chalkboard, whatever you want to use to write down, but you're not going to be able to do this part in your head. Go ahead and take a moment and pause the video here. I'll count to 3 and give you a moment. 1, 2, 3. All right? Go ahead and check this over and make sure that you got all of these numbers. Again, all I did was I took 71 minus 45, that gave me 26. 71 minus 50, 21. 71 minus 55, that gave me 16. 71 minus 65, that gave me 6. 71 minus 70, that gave me 1. Then I took 75 minus 71, that gave me 4. 80 minus 71 gave me 9. 85 minus 71 gave me 14. And 95 minus 71 gave me 24. Okay? Let's move on to the final step. We're almost there, I promise. This is the last step. All you need to do now is you have to take the average of all of those amounts that you just found on that previous slide, and you're going to have to find the average of them. So you have to now add all of these numbers up together, and then divide this by however many numbers you have. So go ahead and find the average of those numbers. I'll count to 3 so you can pause the video again. 1, 2, 3. Your final answer for this problem, your mean absolute deviation, also known as MAD, should have come out to right around 10 and 1/10. Now you give it a shot. I went ahead and wrote up another smaller set of data, and what I'd like you to do is try to find the mean absolute deviation of this set of data. I'll be unpausing it periodically to check in on you and give you each of the 3 steps. So go ahead and pause the video now and do step 1 on this problem. I'll count to 3. 1, 2, 3. Once you add all of those numbers up and divide them, you should have gotten an average or a mean of about 6. I went ahead and rounded the decimal out. So next step, you need to find out how far each of those numbers is from the mean. I'll give you a moment to pause the video and come back with those numbers. 1, 2, 3. All right, time's up. Hopefully you've got all of these numbers. These 2 numbers in particular are very important. A lot of times I'll notice some students not writing those numbers down. You need to know how often the numbers came out to 0. In this case, we do 6 minus 2, that gave me 4. 6 minus 4 gave me 2. 6 minus 5, 1. 6 minus 6, 0, 0. 7 minus 6 gave me 1, and you need those zeros. You're going to be needing them, especially for this next step to make sure that you don't miss anything. The final step, add all of those numbers up and divide them by however many numbers there are, and you should come out with your final answer, your mean absolute deviation. I'll give you one more chance, pause the video, and we'll continue from here. 1, 2, 3. Time's up. Your final answer for this problem, once you've found all of these numbers to be added up, and then divide it by however many numbers there were, you should have come out to a final answer of about 2 for your mean absolute deviation. All right, guys, that's all the time we have for today. Stay tuned next time where we talk about box plots. In the meantime, I'm Mr. A. Have a nice night.